Okay, so in this video tutorial, we are going to solve right triangle. So previously, we have already an idea about right triangles and the different trigonometric ratios. So what do we mean when we solve right triangles? Okay, so when solving right triangles, we are given with, of course, a right triangle, and we are going to find all the measurements of the sides and the angles. So in this case, if we have angle A here, so the opposite of angle A will be our side A. Opposite of our angle B is our side B, and then opposite of our right angle or angle C is our side C, or the hypotenuse. Now, we say we solve right triangles because we look for the measurements of all of the sides. So in this case, side A is equal to how many units? Then side B is how many units? C is also the same. Okay, and then we need also to find the measurements of the remaining angles. So aside from the right angle, so that's measure of angle B and then measure of angle A. Okay, so let's have some examples. Okay, so number one, in right triangle ABC, measure of angle A is equal to 40 degrees and side C is equal to 39 units. So solve the triangle. So in this case, we are given with an angle and also a side. Okay, so we have angle and side. Now, the first thing to do is to draw the right triangle. So, any position of the right triangle will do. Okay, whatever you desire to draw, that's okay, for as long as we can still locate the angles and then the sides. So if this is my right triangle, so right triangle ABC, okay, so we label first. So the first one is measure of angle A is 40 degrees. So this will be 40 degrees. And then our C is 39. So in this case, C is here. Okay, it is the hypotenuse. So that is 39 units. Now, what we are looking for as the measurement are the two sides and the angle. Now, there is no problem with the remaining angle. So this is our angle B. Okay, because if we try to solve for the measurement of angle B, we can immediately solve for that. Now, the sum of the angles in a right triangle is 180 degrees. So, we can already subtract the sum of the two given angles. So, this will be 180 degrees minus, you are given already with 90 degrees here. Okay, and also you are given with a 40 degrees. So, what is the remaining measurement then? So, we just add. So, 90 degrees plus, okay, 40 degrees. Alright? So, that is 180 degrees minus, this is 130 degrees. So, we say that measure of angle B is equal to 50 degrees. So, that's our first measurement. Okay, now, we need to solve for the side A and side B. But, take note that in your right triangle, we are provided already with the measurement of angle A, which is 40 degrees. Now, all we need to do is to choose a particular trigonometric ratio so that we can be able to give the trigonometric ratio and associate it with the missing side. So, just decide whether you're going to use this sine, okay, so cosine, and then tangent TOA. Okay, now take note, we have a given. So, the given here is 40 degrees angle. Okay, so opposite is A. And then you have hypotenuse. So, if you're going to look at the angle 40 degrees, so that is so. Okay, opposite is A, and then hypotenuse is 39. So, meaning to say, we can use sine, okay, the sine 40 degrees, okay, so sine 40 degrees is equal to, okay, A over 39. So, we have the variable a, which we can solve already. Now, in this case, we can multiply both sides by 39, or simply the shortcut way of doing this is to cross multiply. So we multiply 39, okay, times sine 40 degrees. So that is equal to a. Now, if we're going to solve this using our calculator, okay, just type 39 and then times sine 40. No need to input the degrees. Okay, so our answer, if we use calculator, so that is equal to 25 point, say, 1 decimal place, so 0.1. Okay, so the value of a is 25.1. Now, let's look at the b. Okay, so we have already a as 25.1. Now, if we're going to look at b with respect to the angle, so b is adjacent to the angle. And then we have the given again, which is our hypotenuse. So in this case, so that would be cosine. So adjacent over hypotenuse. So we also solve for this. So we have cosine 40 degrees is equal to so adjacent b over hypotenuse, which is 39. So the same process, we just cross multiply. So this will become 39 times cosine 40 degrees is equal to b. So if we use our calculator, we can find the value of b, which is equal to 29.9. So round off to 1 decimal place. Okay, so we're now complete. So we have already our angle B, we have side A, and then side B. Okay, so let's again draw the right triangle. Okay, so this is B, so that is 29.9. This is A, so this is 25.1. Okay, so our angles. Angle A is 40 degrees. Okay, so the value of C here is given, so which is 39. Our angle B is 50 degrees. Alright, and this is our angle C, which is given 90 degrees. Okay, so we are now complete with the right triangle. Let's just summarize our answers. So measure of angle B is equal to 50 degrees. So A is equal to 25.1 and then B is equal to 29.9. So this is how we solve right triangles. Alright, so let's proceed to our example number 2. Okay, so in this case, we have a right triangle. So solve the right triangle with A is equal to 120 and B is equal to 100. Now, take note that from the previous example, we are given with only one angle and one side. But in the second example, we are going to solve the right triangles given two sides. Now, again, the first thing to do is to draw the right triangle. Okay, so I'm going to draw my right triangle again in this orientation. Alright, so this is angle A, B, and C. Okay, so we need to label. So A, angle A, opposite is side A. So this is 120. Then B, angle B, opposite is side B. So B is equal to 100. Now, these are only the two given. Okay, two sides. Now, the first thing to do here is, since we are given with the two sides, we can solve for the remaining side. This is the hypotenuse, so C. Now, we need to find the value of C. Now, we use the Pythagorean theorem. So that is C squared is equal to A squared plus B squared. So C squared is equal to 120 squared plus 100 squared. So C squared here will be equal to so the square of 120 using our calculator. So 120 times 120, that is equal to 14,400. Okay? So plus 100 squared is 10,000. Okay? And then we add. So c squared is equal to 14,400 plus 10,000. So that will be 24,400. And then we get the square root. Alright, so c will be equal to the square root of 24,400 will be 156.2. Okay, so that's our c. Now, we are given with c. What we're going to do next is to solve for the values of the two angles. Okay, so now we are given only with side A here and side B. And if we're going to find the value of A, okay, measure of angle A, we can use tangent, correct? So tangent is TOA. So you have an opposite here, and then you have an adjacent here. So let's see, let's try to solve. So tangent, okay, so tangent A is equal to 120, so TOA, over 100. Okay, now we learned already that if we solve for the value of the angle, we get the inverse. Okay, so that would be A is equal to the inverse tangent, okay, of 120 over 100. So using your calculator, again, you just type, okay, inverse tangent, then 120 over 100. So the value of A is 50.2 degrees. Alright, so that is our angle A. Now, how are we going to solve for angle B? Simply, you just get the sum of the given angles, then subtract it from 180. So we say that our angle B, so measure of angle B, will be equal to 180 degrees, okay, minus, yeah, so we have 90 degrees plus 50.2 degrees. Okay, so that will be 180 degrees minus, so 90 plus 50.2, that is equal to 140.2 degrees. Then let's try to subtract. So 180 degrees minus 140 minus 2, that is equal to 39.8 degrees. Okay, so we have now our value for B, and our figure is already complete. So again, let's try to draw so that we can see that we have solved all of the sides and all of the angles. So we have, this is A, B, and C. So side A is given. So this is 120. Side B is 100. And we solve C as 156.2. Now our angle A is 50.2 degrees. And our angle B is 39.8 degrees. So that's it. This is how we solve right triangles. So again, when we solve right triangles, we need to solve all of the sides. Okay, find the measures of all of the sides and find the measures of all of the angles.